Designing a product in itself is a challenge. There are many steps that we take at Hatch-22 to ensure a successful product launch. But with the global pandemic that has clouded 2020, we have seen shifts in the way we interact with our clients.
And even our own team. With design and product development being such a hands-on process, how do we maintain social distancing protocols and essentially do the job without being completely hands-on? We want to show you how our small yet mighty team of designers and engineers get it done.
Join us for an inside look at our design process and see how we overcame the struggles of designing during a global pandemic. This is Hatch-22.
Previously on Hatch-22,
we actually kind of asked Hatch-22 to incorporate elements of our two favorite designs for the final one to explore.
The next phase of development will be the kind of engineering of this designs.
In Phase 4, now that the industrial design team has validated ergonomics and the rubbish team has selected the design to move forward with, the project now gets passed over to my team. We'll be working on the beam's internal components, creating prototypes and finding ways to get this beam to work as easily as possible. We'll be working with the design constraints defined by the industrial design team. So everything that was defined under this surface model will be working internally now.
Peter did a quick 3D print just to prove out ergonomics. So roughly speaking, proportionally, this is kind of where we're at. Should be more than enough space for electronics. Their electronics is not significant. It's a small PCB and a small battery, and that's about it. We are incorporating some lighting in there. So there will be some LED lighting that needs to be housed there as well.
We had our internal handoff meeting between the ID team and the ME team, and I knew that the client had selected the underarm concept to UA2, and during that time the ID team was refining the concepts, and they built mock-ups to validate the angles, and so I'm not gonna lie, I'm a bit nervous with the mechanism that with the direction that we've selected. It's going to take a lot of effort to ensure that the mechanism operates smoothly.
As far as what's discussed between the industrial design team and the mechanical engineering team, it's really quite simple at the core. It's really just to reiterate and communicate the design intent. Basically, the design team's taking all the key features and experience requirements that we had extracted from the user and from the client and the desires there, and we're really just kind of reiterating that to the mechanical engineering team.
Felipe's biggest concern is actually complexity and reliability of the mechanism that goes in here. He said his biggest fear is that mechanically, his biggest fear is that this thing will fail mechanically while the electronics are still good. He doesn't like the idea of throwing away a perfectly good PCB and battery just because the steel wire in here snapped, right? It's maybe a little bit unfortunate that he voiced that more clearly now, because I think this underarm grip is probably the most complex mechanically of all the options that we showed them. So he mentioned it now, and we're already kind of committed to this underarm. So there's a certain amount of complexity that's just implicit in this configuration, right?
So we had our handoff meeting with our mechanical engineering team. Points discussed were largely focused on the trigger mechanism, because that's kind of the biggest bit that's up in the air, especially with this underarm grip, because we pretty much have to redesign it. There isn't anything in this category on the market that uses this kind of configuration. So a big question mark was, how are we going to have the thin steel wire that activates the gripper? How are we going to have that come all the way up and then go up the handle, make that hard turn up the handle to the trigger to make it work? So that was a main point.
Having Slack and Miro are some of the like the required tools like that we can't live without. We communicate through Slack within our team members, within each channel, with project updates, and through Miro board. That's where we publish most of the artwork, screenshots, if you would, whenever we have our design reviews. It's really versatile, having Slack, Miro, and Google Hangouts all together in one browser window under different tabs. So it allows us to toggle back and forth.
A knee-jerk reaction is that there's, depending on what type of material this is, there could be some friction generated, but more importantly, what I'm seeing is that the mechanical leverage decreases with the stroke of the button, with the stroke of the trigger, right?
Would create a little bit of a mechanism here and from the button you add a pusher, so every time the button goes in, it actually pushes on this mechanism, which will then pivot up and then pull the string.
Now things are in Emmy's hands, in my team's hands, and this is the phase of work where things starts to get real. We're likely going to build and validate, but before that, we're going to put together some ideas, put our heads together, and figure out how this is going to work.
One thing that I think is unique to Hatch-22 is something that I've experienced, but maybe not every designer or every entrepreneur will experience, and it's seeing the engineering cycles and how you have to solve problems on the go and being mindful of the design considerations that have been set. So something that makes it unique within Hatch-22 is that we have our engineering team and design team within the same roof, let's say. So we're always able to cycle back and communicate with each other, but even then, within the engineering process, there's a lot of trial and error, and we have to plan for it. We have to plan for changes to be made, for compromises to be made, and just understanding the impact of those changes and understanding if it's going to change the budget, the manufacturing processes, if it's going to change the ergonomics or the assembly. And all of this is something that we wanted to lead the rubbish team through. So they understood that if there were any setbacks, not only how we already planned for it, but if there's anything extra like human factors, something that we couldn't have accounted for, it impacts the schedule directly.
I just wanted to give you a little bit of a timeline of what we're going to be talking about, and it's mainly just to give you a progress report and give you eyes on the CAD file, the mechanism, and some of the advances that we've done up till now and what our next steps are.
Gave some feedback on some of the preliminary DFM or design for manufacturing stuff that came my way. I had some concerns about some of the features, some of the bosses on the inside not being strong enough. Something is always going to break in a product that you make. Designing where that is to be the least likely place, or designing out of, designing that chain to break further is good. So this is one of the few highlights that I saw.
So we're preparing it for the first prototype. At that point, we can send that file also to Felipe, so him and the electrical engineers can start working on a plan for the electrical components. And for us, we will be able to make sure that not only is everything okay, the ergonomics stayed intact, and then give ID a chance to give us the input necessary to hold this whole of the design intact.
I think, giving the feedback or thinking about how this thing is going to be manufactured early on in the ID iteration process on my part, has maybe guided a little bit of the thinking of how this stuff is going to be done, so that that transition from ID to ME is smoother. So integrating those two things is important, and I think overall will lead to a better product. Having them be separate, like it can be done, but it makes it harder.
Trigger is one of the most important interaction points within the new beam, and we will need to make it right. Overall length had to be shorter as the pivoting point of the trigger was adjusted. The profile of the trigger had to be updated to accommodate the rotation movement of the trigger. Last but not least, we had to make sure the surface details were as intended.
Like we can definitely go shorter. The intention was to actually hold it with 2 fingers, right? So like I would even draw like on the side, like on the as a sketch, I would even draw like a complete circle around this as an axis, and kind of reflect portion of that circle into the side profile.
In terms of if design is involved, but we're heavily still involved, engineering still checks with us, throughout the way. We obviously let them kind of take the lead in terms of like, if there is a trade-off conflict, more times than not, and once it gets into their hands, we've already kind of had our say of what we want. So, if there's like a conflict of like, engineering's like, hey guys, I gotta use this off-the-shelf part, like that's, it's for the cogs and we're gonna have to make the switch here. We're gonna get a chance to say like, okay, then can you choose this off-the-shelf trigger, for instance, to make sure it matches, our overall design. But other than that, like at this point, it's kind of driven by engineering in terms of like the constraints and the needs.
The importance of CAD is that it enables us to be able to understand the behavior of the mechanism. So we can easily, define the sketch, define the length of the link, define the forces that drive each link, and based on the input and the output forces. However, if we don't define it within CAD, we don't understand what those interferences may be. And so if we have a strong understanding of the behavior of the mechanism, then we can build our prototypes with better confidence. So it not only reduces the amount of iterations and phases that we need to prototype, but it saves us time and money in the end.
Scheduling a call actually with Felipe, and once he has had a chance to look at this CAD and maybe print it out himself, I believe he has a 3D printer and he may want to do that so that we can get more information on internal components, and then you can start working on that.
I think we can capture this in the second iteration. Like we can explore different options for snap fitting, for a better serviceability aspect for the design.
Yeah.
The ME team has proposed fasteners, screws essentially, in multiple locations, and then we had to try to work with them to figure out what are the best locations for those screws to be in. Because one thing that we're trying to preserve is this really excellent branding placement, right? So right on the side of the device, we have this perfect billboard area to have rubbish, and that's key. That's critical because we do want brand recognition and we want people to know about what rubbish is doing and the good that they're doing. So we can't have screws and things disrupting that branding and that opportunity there.
hardest challenge of some new clients is that they don't really understand the design process per se, and they think that once they see it and it looks sexy and awesome on the rendering, that it's gonna look exactly like that when we finish the physical product. And 9 times out of 10, that's usually not the case. We can definitely get very close, but there's always some trade-offs, because when you're CADing up stuff in the design process and you're rendering something, at the very end of the day, we're still working, we're physically validating volumes and stuff, but that rendering, that pretty rendering that you see kind of mid-project, that's still, we're playing with pixels, right? But when we're actually engineering the project and the product, then that's where we're playing with atoms and physics. There's just only so much you can do, and so obviously there are going to be some trade-offs, and so that's what we're kind of discussing.
So prototyping, as it pertains to engineering, it allows us to gain better confidence, reduce any sort of risks that we may not be able to foresee. What it does is it allows us to validate whether or not if our design within the CAD environment is a viable design or not. And prototyping enables us to do that within the physical space. So you have the virtual space, which is defined under the CAD constraints, and then you have the physical space. So every time we build something in CAD, we fully validate it by building a physical prototype. And usually that's done through rapid prototyping, 3D printing, additive manufacturing, and so forth. So as we build the first prototype, we get to about a 75% confidence level minimum. And then what we learn from that are, different tolerances that we may need to change based on the fitment, or if there's interferences caused by certain pieces of hardware within the enclosure. So what remains is, in the next 2 rounds of iterations, is likely, 25%-ish or so.
From our first prototype, some of the major learnings that we found were things that you can't really account for when you're working digitally. And even though we did mock-ups, even though we did have a lot of studies around it, once we had our first prototype, we realized that the position of the buttons did not quite match up to our ergonomic goals. So we modified that. We also found that our plan on how the phone mount would be added on to the main shell, it wasn't as strong as we wanted it to be, so we had to go back and revisit that. A major element in this whole process is the fact that we were using a lot of items that were going to be sourced, not made. And so given this huge variable, we wanted to make sure that it was as solidified as possible from our end, so that when it gets to a manufacturing site, they can just make small little changes to adjust for the source part. And a big one for us was making sure that it was secure enough so that it wouldn't topple or it was accessible to assemble. And then last but not least, and a huge important one, is the beam. So we had this idea of the beam being a certain material because our client wants it to light up, which is a really great idea. It's really cool. We loved it. But once we got to the material, which would allow this to happen, the material was just not strong enough. And as much as we tried different versions of that material, we just couldn't get to a solution that gave it the strength and the durability that we wanted for this product. So we had to go back and revisit that area specifically, which proved to be a little bit more complicated than we thought, given that the mechanism runs through that beam, but we ended up solving it. So that works out. Prototypes, they work. So the way that we use prototypes is to validate any changes in the CAD. For example, if we already strategized on the assembly, making sure that it works. If we were planning on using certain materials, making sure that they function the way that we want them to function. So if they don't, we need to then make the changes and revalidate and make sure that upon each validation, we get closer and closer to a CAD that'll be manufacturable as is. That is the main goal, and that's why we had to keep revisiting because we kept encountering issues that were big, that needed to be solved. In our eyes, these were worth exploring and worth finalizing, again, to ensure that this is a successful product, that this is going to do what we promised it would do.
With each round of prototyping, we gain better clarity, and we further reduce the risks, and gives us better visibility within the overall enclosure, because once the enclosure is fully assembled, you can't see the components inside. So one trick we do like to do is we like to print things in clear, and so that gives us sort of a see-through view of how the internal components are behaving. So that's a little insider trick.
Something that we have found has been that working in parallel with the internal components and then trying to also balance some other variables has been a little bit more challenging than we had initially thought. But it's also something that has made this project that much more interesting and challenging. Another tricky item for this has been the mechanism. So making sure that we don't disturb the mechanism on the inner part of the beam with all of our changes on the outside and with the assembly. This is a mechanism that requires a certain amount of tension. So the assembly is a little tricky if you don't do it this one certain way, and so we've had to work around that, and that is going to be a big part of our third validation, making sure that our discoveries and our plans for this are validated and are functioning and are finalized enough so that when we get to the prototyping, the final prototype, the aesthetic one that's going to function, not only does it work the way it's intended, but it also looks the way that it's intended.
When we reach the final iteration, the final prototype, we likely will have PCB boards by then. And so we'll be able to test using the daughter board, the main PCB board, and run wires, route wires, and also have an LED strip along the acrylic housing of the beam.
Something that has been a little bit tricky has been that we've had to accommodate for source parts for which we don't actually have dimensions, since the parts are not sourced yet. So we have to plan for that variable, and it's something that is taking a little bit longer, but we've managed to do by setting ranges and standards, and then also making sure that they line up with the elements that are set. For example, the internal electrical components, the trigger, power buttons, the beam, any of those elements should be completely finalized and shouldn't change.
I have captured all of my feedback, and my third engineer has incorporated the feedback just in time, and we have gathered parts and sent them over to our appearance model maker that is also in transit. So we are on our way to developing and procuring parts and working with our appearance model maker to build our first functional appearance prototype. So we're excited for that. That should happen in the next 3 weeks. But in the meantime, stay tuned for more updates.